All right. This problem says, number 36. One spring day, Elroy noted the time of day and the temperature in degrees Fahrenheit. His findings are stated below. At 6 a.m., the temperature was 50 degrees. For the next 4 hours, the temperature rose 3 degrees per hour. The next 6 hours, it rose 2 degrees per hour. The temperature then stayed steady until 6 p.m. For the next 2 hours, the temperature dropped 1 degree per hour. The temperature then dropped steadily until the temperature was 56 degrees Fahrenheit at midnight. So it kind of walks us through how the temperature is changing throughout the day. Temperature is on the y-axis, and the time of day is on the x-axis. Let's explore these axes and see what they're counting by. So it looks like this little chunk of the graph has been taken out, right? That means the graph isn't going to start at 0. It's going to start at a few little pieces taken out, and then 50. So between 50 and 60, there's 1, 2, 3, 4, 5 boxes. So that means the scale here is counting by 2. So just be careful. You don't want that to trip you up when you're graphing stuff. Okay. So then 6 a.m., it looks like the graph starts at 6 a.m., and then this is going to be 7, 8, 9, 10, 11, and then we'll get to noon, and then 1, 2, 3, 4, 5, 6 p.m., 7 p.m., 8 p.m., 9 p.m., 10 p.m., 11 p.m., and then midnight. The graph is like talking about so many different numbers, so I'm just going to fill them in so I understand what's going on. Okay, great. So now let's take all the information from up top that's highlighted in blue and put it onto the graph so we can somehow get some visual representation of the temperature as the day went on. So at 6 a.m., the temperature was 50 degrees Fahrenheit. So that is a point on the graph, 650. So we're going to go ahead and put 650 on the graph. 6 a.m., 50 degrees. There we go. The graph starts there. Then for the next 4 hours, the temperature rose 3 degrees per hour. So for 4 hours, it rose 3 degrees per hour. That means we had a total temperature change of 12 degrees. So if it rose from 50 degrees up 12 degrees, it's going to end up at 62 degrees. And if it started at 6 a.m. and it goes for 4 hours, we're going to be going to 10 a.m. So we've got 10 a.m., 62 degrees as our next point. So we're going to go ahead and connect a nice smooth line. Use your ruler. Obviously, I can't because I'm on the computer, but a nice smooth line from 10, 62. All right, let's get the next point on the graph. So it looks like the next 6 hours. Okay, so now this is bringing us all the way to 4 p.m. It rose 2 degrees per hour. So at 4 p.m., it rose 2 degrees per hour. So it rose 2 degrees per hour for 6 hours. So that means we have a total degree increase of 12 degrees. So 62 plus 12 more is going to be 74 degrees. So at 4 p.m., it was 74 degrees. Let's go ahead and put that on the graph. At 4 p.m., it was 74 degrees. Okay. Right. And then the temperature stayed steady until 6 p.m. So from 4 to 6, we stayed at a steady 74 degrees. Okay. And then for the next 2 hours, so from 6 to 8, the temperature dropped 1 degree per hour. So that was for 2 hours. So it dropped a total of 2 degrees. So 872 is going to be my next point on the graph. 872. Okay. Oops, that doesn't look good. Okay. And then from 872 to, let's see, the temperature then dropped steadily until the temperature was 56 degrees at midnight. So at midnight, the temperature was 56 degrees. I'm going to go ahead and put that on my graph. At midnight, the temperature was 56 degrees. Okay. All right, so that's my little graphy poo. Let's see. Do we have to label it with anything? No, they don't give us a function. All right, looks good. State the entire time interval for which the temperature was increasing. So when we're looking for intervals of increase, we're going to look for the spots where the graph is going up as we read from left to right. So we're increasing from here to here, and again from here to here. Oops. And then it looks like we kind of level off and we're constant here. And then we are decreasing for the remainder of the graph. So the intervals of increase, or the entire time interval for which the temperature is increasing, is from 6 a.m. to 4 p.m. And then after that, the graph is either constant or going down. Then it says determine the average rate of change in degrees per hour from 6 p.m. to midnight. So average rate of change, we know that that means slope. So we are going to calculate the slope from 6 p.m. to midnight. So let's go ahead and get a point for 6 p.m. At 6 p.m., the degrees were 74, or the temperature was 74 degrees. Sorry, that was a weird way to say it. And then at midnight, the temperature was 56 degrees. Okay. So we're determining the average rate of change over this interval. 56 degrees. Sorry. Okay. So let's go ahead and make our little f of x chart. Or I guess since we're dealing with, whatever, it's fine. We're going from 674 to 1256. So to get from 6 to 12, I'm going to add 6. And then to get from 74 to 56, let's go ahead and figure that out on our calculator. 18. We're going down 18. So this is going to be my change in y. This is my change in x. The average rate of change, or the slope, is equal to the change in y over the change in x. Let's go ahead and substitute. The change in y is negative 18 divided by positive 6. That leaves me with negative 3 degrees per hour as the rate, or the average rate of change from 6 p.m. to midnight.